Welcome to the Deep Dive. Today we're taking a practical plunge into a topic absolutely fundamental for anyone stepping into the modern business world: spreadsheets. If you're a Dr. Sampak College of Business student, or really any college student or professional keen on management, business operations, or information systems, well, this deep dive is crafted specifically for you.
That's right. Our mission today is to simplify what can sometimes feel, like a daunting tool. We want to help you grasp the core concepts and ideas from the Spreadsheets module in Management Information Systems.
Yeah, the goal is really to arm you with the knowledge to not just use spreadsheets, but to leverage them strategically.
Exactly, making you more effective, more adaptable in navigating all those business challenges you're going to face.
Okay, before we unlock these insights, maybe take just a quick moment to like this deep dive, subscribe to the deep dive, follow us on your favorite platforms, and definitely share this with anyone who needs to get a handle on spreadsheets.
Yeah, and your comments and questions, they really fuel our conversation.
Okay, let's unpack this. So our primary source for this deep dive is Richard Tedmon and Casey Wilhelm's Connect Master: Management Information Systems. It's published by McGraw Hill, 2024 edition. It's a fantastic resource for practical knowledge. And to really set the stage, let's go back to that independent bookstore example we talked about.
Yeah.
Imagine you've just been hired there. The owner, wonderful person, but she's currently drowning in inventory chaos.
Right, common problem.
She's been using a simple spreadsheet, but honestly, it's just not cutting it. Customers are asking for books. Maybe they only know the genre or the title, but not the author.
Or maybe it has multiple authors.
Exactly. And books get sold, but they're not always removed from the list. So there's constant frustration. It's a mess that's costing her sales and time.
And this is precisely where your understanding of spreadsheets becomes a total game changer. As the new hire, you wouldn't just organize, you'd actually transform her entire operation. Well, you could introduce filters, right? So she can instantly pull up all, say, mystery novels, or quickly see which books by multiple authors are actually in stock. You'd add columns for crucial details like date last sold or copies available. This lets her see real-time inventory. It's not just about tidying up, it's about making her data, well, actionable.
So how does turning that raw data into something actionable fundamentally change your business? I mean, beyond just being organized.
Oh, it's transformative. Seriously. With that organized, dynamic data, you can build powerful visual tools charts that instantly show her, say, the best-selling genres by quarter, or maybe which authors consistently fly off the shelves.
Okay, so seeing patterns.
Exactly. This isn't just understanding what happened, but starting to figure out why. It lets her optimize her inventory spend, maybe predict demand for specific genres, even identify untapped market niches, perhaps.
Right.
She moves from just reacting to sales to proactively shaping her business strategy. She's turning raw data into a real competitive advantage. That's the power spreadsheets bring.
That real-world scenario, yeah, it really highlights the strategic impact of this tool. Okay, so let's begin our deep dive into the foundation, what spreadsheets are and how we use them. So at its core, a spreadsheet is basically a computer program that lets you arrange, calculate, and present numerical data in an organized grid.
Right. Think of it as a super-powered ledger. It's got built-in formulas for sometimes complex computations and the ability to convert all that raw data into clear, compelling charts and graphs.
It really does make numbers tell a story, doesn't it?
It does. And these digital workbooks aren't just for one area. Their applications span nearly every field imaginable. In business, like we just saw, they're indispensable for budgeting, accounting, tracking financial trends, and critically, for forecasting and making strategic decisions.
Okay.
Personally, you might use them for organizing your budget, tracking investments, maybe calculating loan payments. In academia, professors use them for grading, maybe curving exams, managing research data, even in sports, tracking stats, player performance, analyzing game data.
Wow. Okay. So they really are everywhere.
Spreadsheets are truly a universal language of data.
It's fascinating how universal they are. And while they all sort of serve similar purposes, you'll mainly encounter four main types. Microsoft Excel, obviously.
The big one.
Yeah. Then there's OpenOffice Calc, Google Sheets, which is great, cloud-based, and Apple numbers.
All right. And while each has its own interface quirks, the core functions we're talking about today, they're largely consistent across all of them.
Good to know.
Now, understanding file management is pretty foundational, whichever program you use. Opening a blank spreadsheet is generally pretty intuitive.
Yep.
Whether it's Excel, Google Sheets, OpenOffice Calc, Apple numbers, You typically launch the app and select something like blank workbook or blank spreadsheet to start. The exact clicks might vary a tiny bit, but the idea is the same.
Okay. And saving. Are there common pitfalls there, especially since different programs handle it differently?
That's a good question. Saving your work is obviously non-negotiable if you want to use it again, and the main pitfall is assuming it's always automatic.
Ah, right, like Google Docs.
Exactly. Google Sheets cleverly auto-saves your changes as you work. So you pretty much just name your sheet and close it when you're done. But other programs like Excel or OpenOffice Calc, they usually need a manual save or save as from the file menu.
Okay.
It seems small, but forgetting that click, it can lead to a lot of lost work. Definitely something to keep in mind.
Right. So with that foundation laid, let's peel back another layer and look at the structure understanding spreadsheet building blocks. These are like the very atoms of your data, right?
Exactly. The fundamental unit is the cell, that single box where all your data lives. Each cell has a unique cell address identified by its column letter and row number, like say B4.
B4, got it.
When you click on a cell, it becomes the active cell. It gets highlighted, usually with a border, and often the row and column headers are highlighted too. You'll even see its address pop up in a name box in programs like Excel.
Okay.
And those cells, they're organized into rows and columns. Rows run horizontally, they have numbers. Clicking a number selects that whole row. Columns run vertically, they have letters. Click the letter, you get the whole column.
Simple enough.
Then you have labels. These are just text entries that identify your data, things like product name or revenue.
Okay.
And here's a quick pro tip. If you need a number to act as a label, like maybe a zip code or a product ID like 001, type an apostrophe right before it.
Oh, why is that?
Because otherwise the spreadsheet might think it's a number for calculation and it might drop those leading zeros or format it weirdly. The apostrophe tells it, hey, treat this as text.
Ah, good tip.
Okay.
And that leads us to values and the equal sign.
Right. A value is any entry the program can work with numerically. So numbers, dates, things like that. And here's the golden rule. You absolutely have to remember this. For any calculation, you must start the entry with an equal sign.
Always.
Always. No equal sign, no calculation happens. The spreadsheet just sees it as text or a plain number.
Okay. Equal sign is critical. Got it. And you mentioned pointers briefly.
Yeah, just quickly. As you move your mouse around, you'll notice the cursor, the pointer, changes shape. It might be a plus sign, an arrow, an I-beam. Each shape tells you what action you can perform right then, like selecting cells or dragging to fill a series or resizing a column. You get used to them pretty quick.
Right. Okay. And speaking of formulas and potential issues, gotchas, error values.
Yes, inevitably you'll run into some common error values. Don't panic when you see them. They're just the spreadsheet's way of saying, something's not quite right here.
Okay, like what?
Well, you might see #valueless. That usually means an operation isn't logically possible. Like you tried to add a number to a word like panda. Doesn't work.
Right, makes sense.
Then there's #DIZ0. That one's pretty clear. You tried to divide a number by 0. Math rule can't do it.
Okay.
And #REF means there's an invalid cell reference in your formula. Maybe you deleted a cell that the formula was pointing to or something like that.
Gotcha. And then there's the one that always used to freak me out, the string of pound signs, #tag, filling the whole cell.
Ah, yes. That one looks like a huge error, doesn't it?
Totally.
But it's actually the easiest fix. It simply means the column isn't wide enough to show the whole number or date.
Oh.
Seriously.
Yep. Just grab the edge of the column header and drag it wider. Your value will appear. It's not a real error, just a display issue. Super common for new users, but thankfully, a simple fix.
Okay, that's a relief. So you've got your data in, you understand the basic structure. Now let's talk about manipulating data essential operations. Knowing how to insert and delete rows and columns feels pretty fundamental.
Absolutely essential. Things change, you need to add data or remove it.
Yeah.
Most programs make it easy. You usually right-click on a row number or a column letter, and you'll see options like insert or delete. It's quick for restructuring on the fly.
Right. And you mentioned something earlier, the fill handle. You said it was a big time saver.
Oh, it's huge. That tiny little square in the bottom right corner of the active cell, it's incredibly powerful.
Yeah. How so?
Well, let's say you type January in a cell. Grab that little square handle and drag it down or across. Yeah.
It automatically fills in February, March, April, and so on. Same for days of the week. Or even number sequences. Like if you type 1, then 2 in the next cell, select both, and drag. It'll continue the pattern. 3, 4, 5.
Whoa, okay. That is useful.
It's an often overlooked feature, but it boosts efficiency like crazy, especially when you're setting up lists or sequences.
Nice. Okay, and when you need to apply a function or format specific data, selecting cells is key. How does that work if they aren't next to each other?
Good question.
Huh.
For cells that are right next to each other, what we call adjoining cells, you just click and drag. Easy.
Right.
But for cells that aren't touching non-adjoining cells, say you need data from column A and column F, but nothing in between, you hold down the cater key on a PC
Okay.
or the command key on a Mac while you click each individual cell or drag over each separate range you want.
The Catril command key trick.
Yep. It gives you really precise control over exactly which bits of data you're working with for calculation or formatting.
Makes sense. And what about making things easier to read, like hiding stuff or freezing panes?
Yeah, super important for large data sets. You can freeze panes, usually your header row or maybe the first column, so they stay visible even when you scroll way down or across. You typically find this under the View tab.
That's really useful for keeping track of what column is what.
Totally. And you can also hide entire rows or columns if they're distracting or not needed for a particular view. Just select them, right-click, choose Hide.
And getting them back.
You'll usually see a little double line where the hidden row or column is. Right-click near that line, and you'll see an Unhide option. It just keeps your workspace clean without deleting anything.
Cool. Okay, speaking of data utility and sharing, let's talk about comma-separated format files, CSVs. Sounds a bit technical, but you said it's important for business.
Oh, it really is. A CSV file is basically a plain text format. Its whole purpose is to allow data to be shared universally between different spreadsheet programs or even database programs.
How does it do that?
Its genius is its simplicity. It saves only the cell, values the actual text and numbers separated by commas. It strips away all the fancy stuff. Formatting, formulas, colors, everything.
Why is that stripping away good?
Because it guarantees compatibility. Imagine you need to send your sales data to a partner, but you don't know if they use Excel, Google Sheets, or something else entirely. Or you need to import a customer list into a new system.
Right.
A CSV file ensures that the raw data, the core information, is accessible and readable by pretty much any program. It's like the lowest common denominator for data exchange, which is vital in business.
Okay, so it's about making sure anyone can open and use the basic data.
Exactly. And just quickly, yes, you can usually save or download your spreadsheet from programs like Google Sheets or OpenOffice Calc as an Excel file if needed, usually through the file menus, download as or save as options. That keeps more formatting intact if you know the recipient uses Excel.
Okay, this is great. Now we're getting into the real power, harnessing power functions and advanced features. This is where spreadsheets go from just organizing data to actually analyzing it. Right?
Absolutely. This is where the magic happens. Let's start with cell referencing. This is crucial for building formulas that can be copied effectively.
Okay.
The default is relative referencing. That means if you write a formula, say A1 plus B1 in cell C1, and you copy that formula down to C2, it automatically adjusts to A2 plus B2.
Right, follows the pattern.
Exactly. But sometimes you don't want a reference to change. That's where absolute referencing comes in. Use dollar signs like A1 dollar.
Dollar sign.
Yep. Putting a dollar sign before the column letter locks the column. Putting 1 before the row number, $1, locks the row. So A1 locks both. No matter where you copy that formula, it will always refer back to cell A1.
Oh, okay. When would you use that?
A classic example is calculating sales tax. Let's say your tax rate is in cell E1, and you have a list of prices in column B you want to calculate tax for in column C. Your formula in C2 might be B2E1. When you copy that down, B2 will become B3, B4, etc., but E1 will always point to that single tax rate cell.
Got it. That makes perfect sense. Fixes one part, lets the other change.
Precisely. And beyond building your own formulas, spreadsheets have tons of common built-in functions that save immense amounts of time.
Like?
Well, there's AutoSUM, usually a button with the Greek letters, sigma. You just select the numbers you want to add, click it, boom, sum calculated. Then there's average, count, which counts how many cells in a range have numbers. MIN finds the smallest value, and max finds the largest. These are like your daily toolkit for quick analysis.
Okay. Now, one function I always found super practical, maybe for personal life, but also business, is the payment function. Can you unpack that?
Oh, yeah. The payment function, or PMT, is fantastic for financial modeling. It calculates the constant periodic payment for a loan. Think a car loan, mortgage, maybe even business loans or leases based on a constant interest rate.
So what do you need to tell it?
You need to give it three main things: the interest rate per period, the total number of payment periods, and the loan amount, which is the present value.
Okay. Any pitfalls there?
The big one, a really common mistake students make, is forgetting about the periods. If you have an annual interest rate, say 6%, but you're making monthly payments, you need to divide that rate by 12 for the function. So 6 per 12 for 0.5% per month.
Okay. Rate per period.
Exactly. And same for the number of payments. If it's a 5-year loan with monthly payments, the total number of periods isn't 5, it's 5, 12 equals 60.
Right. Got to convert everything to the payment frequency. Monthly, usually.
Usually monthly, yeah. Get that right, and the PMT function is incredibly useful for figuring out affordability, comparing loan offers, or for businesses, modeling debt payments and cash flow impacts.
Very useful. Okay, what about the IF function? That's like it makes decisions.
That's exactly what it does. The IF function introduces logic. It lets you tell the spreadsheet. If this specific condition is true, then display this result. Otherwise, if it's false, display this other result.
Can you give an example?
Sure. The classic one is grading. A professor could write a formula like IF B264, pass, fail.
Okay, so if the score in cell B2 is greater than 64,
then the cell with the formula will show the text pass.
but if it's not?
Then it shows fail. You set it up once in the first row, copy it down, and it automatically grades everyone based on that simple rule. It's fantastic for automating decisions based on data criteria.
Yeah, I can see that being useful. And you mentioned named ranges, especially in Google Sheets.
Yeah, this is a really handy feature for making complex formulas easier to read and manage. Instead of having a formula that looks like Esium sheet1.a1.d25, which can be confusing, you can select that range of cells, A1 to D25, right-click, and give it a name, maybe something like Q1 sales data. Then your formula just becomes SUM Q1 sales data. Much clearer.
Oh, definitely.
Yeah.
Much more intuitive. Okay, now for the real power tools, PivotTables. These sound important for business intelligence.
They're absolutely transformational for exploring and summarizing large data sets. Let's go back to our bookstore owner. Imagine she has years of detailed sales records, date, book, genre, price, maybe customer ID.
Okay, lots of raw data.
A pivot table lets her, or you, instantly reorganize and summarize all that data without writing complex formulas. You could, in just a few clicks, see total sales broken down by genre, or by month, or see which specific books sold best in Q3, or maybe compare sales by different marketing campaigns she ran.
Wow, so you can just pivot the data to look at it from different angles.
That's exactly why they're called pivot tables. It empowers managers and analysts to ask spontaneous, complex questions of their data, like, what was our average sale price for sci-fi novels sold on Tuesdays in October, and get immediate answers. It's rapid, ad hoc querying. No need to wait for a data analyst report for many common questions.
That sounds incredibly powerful for quick decision-making.
Yeah.
And related to finding information, VLOOKUP and H.Lookup, what do they do?
These are powerful search functions. VLOOKUP stands for vertical lookup, and H.Lookup is horizontal lookup. They let you retrieve specific pieces of information from a table based on a unique identifier you already know.
Okay, like what? Another bookstore example.
Sure. Imagine the owner has her main sales list and a separate sheet with details about her loyalty program members, maybe their name, email, total points, favorite genre.
2 different tables.
If she wants to quickly find the email address for a customer named Jane Doe who just made a purchase, she can use VLOOKUP. She tells it, look for Jane Doe in the first column of the loyalty member table, and when you find her, give me the value from the, say, third column, which contains the email address.
So it finds the right row based on the name, then pulls data from a specific column in that row.
Exactly. VLOOKUP searches vertically down the first column of a table to find a match. H.Lookup does the same thing, but searches horizontally across the first row. They are essential tools for connecting related pieces of data scattered across large spreadsheets, saving hours of manual searching or copy-pasting.
Okay, we've covered structure, manipulation, functions. Awesome stuff. Now let's talk about making sense of it all visually, visualizing data and math principles. Because numbers are great, but charts and graphs make data way more understandable.
Right.
Especially for presentations.
Absolutely critical. A good chart can convey insights almost instantly. The main types you'll use are bar graphs, really good for comparing distinct items like sales figures for different products, or showing changes over specific periods.
Oh.
Then you have line graphs. These are perfect for showing trends and how things change continuously over time, like website traffic month over month.
Right, seeing the ups and downs.
Exactly. And of course, pie charts. Best used when you want to show how different parts make up a whole, like the percentage breakdown of expenses in a budget, or maybe the market share of different competitors.
Okay, bar, line, pie. Got it.
Mm-hmm.
But just making a chart isn't enough, is it? What makes a good chart?
Clarity is key, and that comes down to having clear chart elements. Every effective chart needs a descriptive title. What is this chart showing?
Makes sense.
It needs clear axis identifiers or labels so people know what's being measured on the horizontal x-axis and the vertical y-axis. Units are important here too.
Right. Is it dollars? Units sold.
Precisely. Data labels can be helpful too, showing the exact value for each bar or point, though sometimes they clutter things up. And a legend is crucial if you have multiple data series, like different product lines on the same line graph. The legend tells you what each color or line style represents.
Okay, title, axes, labels, legend. Good checklist.
These elements turn a potentially confusing graphic into a clear, compelling story.
And what about color? Does that matter beyond just making it look nice?
Oh, definitely. Color theory in spreadsheets isn't just about aesthetics, it's about enhancing readability and conveying meaning quickly. Good color choices make data easier to scan, help differentiate categories, and can highlight important trends or outliers.
Any tips there?
Well, using a color wheel to pick complementary colors can make charts more visually appealing and easier to read than just using random bright colors. Also, be aware of common conventions. In finance, red often means negative numbers or losses, while black or green means positive.
Right, red ink.
Exactly. And for things like risk analysis, you often see green for safe or good, yellow for caution or intermediate, and red for danger or critical. Using color purposefully guides the viewer's eye and adds another layer of information.
Okay, good point. Use color strategically. Now let's quickly refresh some basic math principles that spreadsheets rely on, starting with the order of operations.
Yes, good old PEMDAS or BODMAS, depending on where you learned it. Parentheses, or brackets, exponents, or orders, then multiplication and division, done from left to right, and finally addition and subtraction, also left to right.
And spreadsheets follow this.
Absolutely, rigidly. If you write a formula like 5 plus 23, the spreadsheet will calculate the multiplication first, 23, 6, and then the addition, 5 plus 6, 11. If you wanted the addition first, you'd need parentheses, 5 plus 2, 3, which gives 21. Understanding PEMDAS is crucial for getting the right answers from your formulas.
Okay, PEMDAS matters. What about percentages and averages? We use those all the time.
Definitely spreadsheet staples. To calculate a percentage of a number, like 20% of a number, like 20% of 150, you just convert the percentage to a decimal, 20%, 0.20, and multiply. 0.20150 equals 30.
Simple enough. Percent change.
A bit more involved, but common. The formula is new value, original value. Then you multiply by 100 to express it as a percentage. So if sales went from 100 to 120, it's 100.20 or a 20% increase.
Okay, new, old, got it. And averages. There's more than one type.
Right. The most common is the mean, which is what people usually mean by average. Sum up all the values and divide by the count of values.
Okay.
But there's also the median, which is the middle value when all the numbers are sorted in order. This is often better than the mean if you have extreme outliers that might skew the average.
It's like one huge sale messing up the average sale price.
Exactly. And finally, the mode is simply the value that appears most frequently in a data set. Each type of average tells you something slightly different about the center of your data.
Okay. Mean, median, mode.
Yeah.
Good to remember. Lastly, let's just quickly touch on loan payments and future value concepts again.
Sure. When you're dealing with loans, especially using functions like PMT, you need to understand the key factors. Present value, PV, is the initial loan amount. The interest rate is usually the APR, but remember to adjust it per period, like monthly. The term is the length of the loan. Often in years needs converting to periods. A period is a single payment interval. And the principal is just another term for the present value or initial loan amount.
Right. And future value.
Future value, FV, is a core finance concept. It tells you what a sum of money today will be worth at some point in the future, given a certain interest rate or rate of return. Or, in the context of a loan, it represents the total amount the loan is worth to the lender over its entire life, the principal they lent out, plus all the interest they'll receive.
So it shows the time value of money.
Exactly. For example, that $20,000 loan we mentioned earlier, at 10% APR for 5 years, its future value to the lender, considering the interest earned, might be around $25,500. It's crucial for understanding the true cost of borrowing or the potential return on an investment over time.
Okay. And you mentioned a quick rule.
Yeah, just a handy mental shortcut, the rule of 72. If you want to quickly estimate how long it takes for an investment to double in value, just divide 72 by the annual interest rate as a percentage. So at 8% interest, it takes roughly 72.8 it will 9 years to double. It's not exact, but it's surprisingly close for quick estimation.
Wow, what an incredible deep dive into spreadsheets. I mean, you can really see why this isn't just some basic computer skill anymore.
Yeah.
It's a truly indispensable tool for any Dr. Sam Pack College of Business student, and honestly, any professional looking to succeed in management, operations, anything really.
Absolutely. That ability to organize, analyze, and then visualize data effectively, it's just foundational to making smart, informed decisions and actually driving business success.
Totally agree.
So, thinking about everything we've covered today, all the power, the functions, the visualization, what's maybe one specific function or feature that really resonated most with you? And how do you personally envision using that feature to directly impact your future career decisions or strategies?
That's a great question to ponder. Really makes you think about applying this stuff. As you reflect on that, remember to like this deep dive, subscribe to the deep dive, definitely follow us on your favorite platforms, and share this with anyone else who needs to get up to speed on spreadsheets.
Yeah, and please comment. Let us know your answer to that question or any other insights you had. We really do want to hear from you.
We absolutely do. Until next time, keep exploring, keep learning, and keep diving deep.